Saturn 1B quarterly film report, number 25, covers progress during the period July, August, September 1965. Highlighting this quarter was the successful launch and flight of the 10th Saturn 1 SA-10, successfully closing out the Saturn 1 launch vehicle program with 10 successes out of 10 scheduled launches. Late last quarter, the launch vehicle had been erected at the Cape and pre-launch testing started. The spacecraft, consisting of Pegasus C within the boilerplate service module plus the command module, was erected atop SA-10 on July 2nd. The overall flight objectives of SA-10 were to continue development of the launch vehicle iterative guidance mode, continue evaluation of system accuracy, and place the Pegasus meteoroid technology satellite in near-Earth orbit. The function of the Pegasus is to provide meteoroid data in near-Earth space. Pre-launch checkout of SA progressed satisfactorily. Following checkout, countdown demonstration testing was successfully completed. Countdown began within the scheduled time frame. SA-10 liftoff occurred July 30th at 8 a.m. Eastern Standard Time. The first stage, the second manufactured by the Chrysler Corporation, burned for 148 seconds, separated, and fell away. The Douglas-built second stage burned about 480 seconds, obtaining programmed cutoff velocity and altitude. Stage performance was normal, placing the Pegasus in the required orbit. The following scene is from Pegasus B kinescope. The Apollo command and service module jettisoned mechanically, and like its predecessors, Pegasus C's wings were deployed. Pegasus C is presently obtaining information concerning quantity and penetrating ability of meteoroids in near-Earth space. The successful launch of the 10th and final Saturn 1 launch vehicle, SA-10, closed out one of the most successful R&D programs in the history of rocketry. The Saturn 1 program, conceived to develop a heavy launch vehicle, compiled an unprecedented flight record of 10 successful flights out of 10 scheduled launches. The Saturn 1 program has provided more than a heavy launch vehicle. It has provided the technological base now being used in developing Saturn 1B and Saturn V. The Saturn 1 program began at the Army Ballistic Missile Agency in 1958 under the leadership of Dr. Werner von Braun and Major General John B. Medeiros. The purpose of the program under Advanced Research Projects Agency, Order 1459, was to develop a 1.5 million pound thrust clustered engine first stage. Shortly thereafter, the program was expanded to the development of a reliable three-stage heavy launch vehicle for scientific payloads. During the next months, studies were made to determine the most expeditious manner for using existing tooling, hardware, and facilities. The new facilities that would be required for testing this new and large vehicle, and the optimum upper stages. One of the results of these studies was the awarding of a contract to the Douglas Aircraft Company to develop and manufacture the second stage. Douglas began work immediately. During the same time period, ABMA started development of the first stage, consisting of a cluster of 9 tanks and 8 H-1 engines. The engines were an improved version of the engine used for the Jupiter and other military missiles. The first stage manufactured was a static firing test stage. During March 1960, technical and administrative control of the Saturn program was transferred from ARPA to NASA. In July, the George C. Marshall Space Flight Center was activated. The nucleus of the center was the von Braun team of rocket experts. In March 1960, test stage static firing was started with the firing of 2 engines. In April, all 8 engines were successfully fired. Throughout the program, the stage was constantly used to static test modifications and design changes to ensure a more reliable vehicle. A final acceptance firing was held in late 1962. Assembly of the first stage, SA-1, got underway May 26, 1960. Following final assembly and flight qualification testing, the first Marshall-built booster was shipped to Cape Canaveral August 1961. The stage was shipped by a barge specially built and modified to move the large flight stage. A few months earlier, during May 1961, the Saturn I was changed from a three-stage scientific satellite launch vehicle to a two-stage man-rated vehicle to support the Apollo program. The design changes caused this decision to be effective with the fifth flight. At Cape Canaveral, SA-1 was erected on the pad with water-ballasted upper stages. At 10:06 a.m., October 27, 1961, the first Saturn I was launched. The flight lasted 8 minutes and was considered highly successful. A second Saturn I was launched April 25, 1962. A third, November 16, 1962. And a fourth, March 28, 1963. All were successful. Flight testing of these vehicles allowed for the continual development of the first stage, including testing of structures, propulsion system and instrumentation, verification of ground support equipment, and development of an engine-out capability. A developed engine-out capability would allow the Saturn to complete its mission with the loss of one engine by diverting propellant to the remaining engines. Meanwhile, the Douglas Aircraft Company continued development, test, and manufacture of the second stage, called the S-4. Following testing and acceptance, Douglas shipped the first S-4 stage by Guppy to the Cape for mating with the fifth Saturn I first stage. The S-4 stage was powered by 6 RL-10A3 engines produced by Pratt & Whitney Aircraft that burned liquid hydrogen and liquid oxygen, producing a thrust of 90,000 pounds. This stage was the largest vehicle using high-energy propellants at the time. SA-5 was launched January 29, 1964. It made a near-perfect flight, placing more than 37,000 pounds, the most weight ever, into Earth orbit. Other milestones included first instrument unit, first redesigned first stage, and initial use of Launch Complex 37B. A sixth Saturn was launched May 28, 1964, again with the first and second stages live, and an orbiting package exceeding 37,000 pounds. Part of this package was an early model of an Apollo spacecraft. The flight terminated the Saturn I R&D flights 4 flights ahead of schedule. SA-7, the first operational flight vehicle, was launched September 18, 1964, and was highly successful. All major test objectives were met. SA-9, launched on February 16, 1965, placed into orbit a Pegasus satellite designed to obtain micrometeoroid information concerning quantity and penetrating ability in the near-Earth orbit. The satellite was developed by Fairchild Hiller under MSFC management for NASA's Office of Advanced Technology. The SA-8 booster was assembled, checked out, and tested at Marshall's Michoud facilities. The Chrysler-built booster was the first industry-produced first stage. Following a contractual agreement in November 1961, Michoud was activated shortly thereafter, exhibiting teamwork between the government and industry. SA-8 was launched May 25, 1965. It was the 9th straight successful Saturn, placing the second meteoroid satellite in near-Earth orbit. SA-10's flight closed the Saturn I program with a completely successful record. The Saturn I program made great strides in guidance, propulsion, and aerodynamics, and these capabilities are already being applied in the Saturn 1B and 5 program. Component installation for the first flight Saturn 1B instrument unit, designated 201, was completed August 26th. The instrument unit's checkout station at IBM's Huntsville facility was activated in late August, and checkout of the first flight instrument unit began. Checkout continued through September, with shipment to KSC scheduled for October. On August 8th, at Douglas's Sacto facility, the first flight S-4B stage was successfully fired for a period of 453 seconds. Previously, 2 long-duration static firings of the stage were attempted, but each was terminated seconds after ignition due to ground support equipment problems. Post-static modifications and checkout were then conducted through August 15th. The stage was removed from the test stand August 28th and prepared for shipment. On September 3rd, it was trucked to Cortland Dock, loaded aboard a barge for river shipment to San Francisco. There, the stage was transferred to a commercial ship for shipment through the Panama Canal to KSC. Structural modifications and pre-erection checks were performed. At Michoud Assembly Facility, the Chrysler Corporation completed post-static checkout of the first Saturn 1B flight booster on July 19th and began preparing S-1B1 for shipment to KSC. On August 9th, the booster departed Michoud by barge with the facility's checkout instrument unit. This instrument unit arrived at Michoud in late June from MSFC. Arriving at KSC on August 24th, the stages were prepared for erection. On August 11th, the flight booster was erected on Launch Complex 34 for facilities checkout. 5 days later, the S-4B facilities checkout stage, which had been delivered to KSC on June 30th, was erected atop the flight booster, followed shortly by the facilities checkout instrument unit. After mating the spacecraft facilities verification vehicle with the Saturn 1B launch vehicle, a checkout was conducted that verified the compatibility of the launch facilities and the space vehicle. While pressure checks were being conducted on the booster September 10th, excessive pressure was inadvertently applied, collapsing the aft bulkhead of the instrument compartment of fuel tank number 1. Upon completion of the remainder of checkout and removal of ground test upper stages September 28th, the damaged tank was replaced with a tank from S-1B6. To minimize potential schedule impact, tank replacement was accomplished in 1 day without removing the booster from the launch complex. 2 days later, the flight S-4B was removed from hangar AF and stacked atop the booster. Early next quarter, the flight instrument unit will be erected, completing the assembly of the first Saturn 1B launch vehicle. At Marshall's Saturn 1B dynamic test area, modifications to the test stand, changeover to upper stage configuration, and reinstallation of upper stages was completed July 29th. This configuration simulates the Saturn 1B flight after the booster is expended and falls away. Dynamic testing is conducted to verify the filter design of the launch vehicle guidance system. Upper stage dynamic testing continued through the quarter with completion of testing September 11th. Analysis of test results is in process. Following successful 1B dynamic testing, conversion of the upper stages to the proper configuration for Saturn V dynamic testing was begun. Structural testing of the General Dynamics built instrument unit segments was successfully completed by MSFC July 22nd. The first 3 flight instrument unit structures will be built from General Dynamics segments. During August, an IU structure designed to verify the structural integrity of the IU shells to be produced by North American Aviation was rejected by MSFC due to discrepancies. At the direction of Marshall, IBM has begun assembly of a second test article from other NAA segments. Structural testing of this article will start next quarter. At Marshall, S-1B2 underwent 2 successful routine static firings, the first on July 9th, the second on July 20th. The stage was then shipped to Michoud August 1st, arriving August 6th. Modification and repair to the stage continued throughout the quarter. Delivery to KSC is scheduled for mid-December. Also, at Chrysler Michoud, S-1B3 checkout, started late last quarter, was completed August 14th. Preparations for stage shipment to Marshall continued to September 9th. It was shipped by barge the same day, just in advance of Hurricane Betsy, arriving at MSFC September 16th. Static testing is scheduled for October. S-1B4 assembly continued through the quarter. Pre-static checkout of the stage will begin in early October. Stage fabrication for S-1B5 was completed July 15th. Tank clustering started the same day and was completed in late August. Stage assembly continued through the remainder of the quarter. S-1B6 stage fabrication started last quarter, continued through this period with tank clustering expected to begin next quarter. S-1B7 fabrication was begun August 19th with fabrication of the lower thrust ring. Fabrication of the upper thrust ring began August 26th. Work continued through the remainder of the quarter. At Douglas's Huntington Beach facility, S-4B-202 checkout was terminated August 12th. Following modification, the stage was transported to Sacto. It was then offloaded and installed in Beta Test Stand number 3 the morning of September 2nd. Pre-firing operations are in process with static firing and delivery to Cape Kennedy scheduled for next quarter. S4B-203 checkout began August 14th, and it underwent final component installation through September 17th. 204 assembly started last quarter, continued with joining of the forward and aft skirt and thrust structure. Installation of the 205 LH2 tank was interrupted in early September to allow modifications and repair. Meanwhile, S4B-206 work progress continued with joining of the forward and aft common dome to form the common bulkhead. Following completion of Saturn V S4B battleship testing August 20th, preparations began for converting Beta Stand 1 for static firing S4B flight stages. At IBM Huntsville, SIU-202 component installation started last quarter, continued through September, with completion and checkout scheduled for next quarter. Shipment to the Cape is scheduled in December. SIU-203 structural assembly was completed in early September. Component installation is in process with completion of assembly scheduled for next quarter. SIU-204 structural segments furnished by North American Aviation were received at IBM September 15th and are now in rounding out operation. At KSC, mechanical and electrical ground support equipment was delivered during this quarter for use at Launch Complex 34. Final electrical equipment installation is underway. At Marshall, the second J2 engine delivered by Rocketdyne underwent initial static firing during August in the center's S4B battleship test stand. Rocketdyne's J2 engine flight rating test series, begun last quarter, was completed July 21st at Santa Susana. 25 firings were conducted for a total performance of 46 minutes. Deficiencies will be corrected prior to completion of engine qualification. FRT engine number 2023 was disassembled for engineering inspection in August. Engine number 2032 was acceptance tested, and 200K qualification test series began at Delta II test stand in August. Qualification tests are due to be completed late next quarter. A new device called a 4-axis numerical control measuring inspection machine is being used by Rocketdyne in connection with J2 injector assembly. It permits time reduction as well as increased reliability of measuring data and fulfills Rocketdyne's integrated systems approach of using numerical control from design intent to finished component. At Michoud, cleanup and repair of the facility is still underway as a result of Hurricane Betsy. The wind and high water damaged facilities at Michoud in varying degrees. Barges were beached, windows were shattered, and much of the roof damaged. However, no impact on Chrysler's S-1B schedule is expected as a result of the hurricane. Marshall Space Flight Center has been following with great interest the progress of the Super Guppy, built and financed by Aerospace Lines Incorporated. On September 17th, the Super Guppy, based on the Boeing Stratocruiser aircraft, landed at Redstone Airstrip at Huntsville. It is the only aircraft capable of carrying an S-4B, an assembled instrument unit, and certain Apollo spacecraft items. In summary, the months July, August, and September witnessed the close of the highly successful Saturn I program and attainment of major milestones within the 1B program. Preparations for the flight of Saturn 1B. Continued Saturn 1B stage buildup. Activation of Marshall's battleship stage facility. Assembly, delivery, and testing of ground support equipment, and new methods of transportation.